a hot brother and his cool sister. While the appearance of El Niño is always accompanied by a warming anomaly in the eastern Pacific, La Niña, as its counterpart, sets off a cooling anomaly. Essentially, we are dealing here with changes in the pattern of ocean and air currents in the tropical Pacific. Together with neutral phases, El Niño and La Niña form a sort of climate swing called the El Niño Southern Oscillation, or ENSO for short. The neutral or normal phases refer to the years in which the trade winds blow from east to west along the equator over the Pacific, or in other words, from South America to Southeast Asia, pushing the warm water of the ocean before them. As a result, the warm water masses accumulate off the shores of Southeast Asia, while colder water from the deeper ocean regions flows off the coast of South America. Essentially, the Western Pacific is a few degrees warmer than the Eastern Pacific. But when an El Niño phase is on the horizon, which happens on average every 2 to 7 years and lasts around a year, the tropical trade winds blow significantly more weakly or even stop blowing altogether. Normally, this happens in the fall and winter in the Northern Hemisphere. Thus, the Pacific Ocean off South America heats up while it cools down in Southeast Asia. In La Niña years, the wind shifts course. In other words, the trade winds now blow much harder than in the neutral phases. This is usually the case every 3 to 5 years, although La Niña events can sometimes occur over several consecutive years. Either way, however, both phenomena are linked to distinct, recognizable weather changes that have unique, though equally extreme, effects depending on the region. In El Niño years, the Pacific shores of North and South America tend to get wetter, primarily because more water evaporates from the warmer Pacific. On the other hand, La Niña causes greater dryness here, while Southeast Asia and Australia experience increased rainfall and flooding. You might think that you are safe from extreme weather outside of the impacted areas, but that is not the case. This is because the ENSO system can indirectly influence regions that are not in its direct catchment area through so-called teleconnections. For example, the Horn of Africa is more likely to experience droughts during La Niña phases, even though the European climate is determined by the Atlantic. The direct effects of El Niño and La Niña events are only reflected in probabilities here. It is possible, for instance, that it rains slightly less in Scandinavia and a little more in Central and Southern Europe during El Niño. Years of lost harvests and winged disease carriers. While La Niña leads to lower temperatures and El Niño causes a thermometer to climb, we shouldn't overlook that the corresponding weather changes have been affecting our everyday lives for much longer than just a few years. In fact, the term El Niño was already coined in the 17th century by South American fishermen. More precisely, they referred to the phenomenon as El Niño de Navidad, or Christmas child, for the very simple reason that the climate anomaly usually reached its peak around Christmas time. Despite this, the fishermen didn't have an especially great time during such phases because, with the increasing occurrence of El Niño years, fewer and fewer nutrients were brought to the surface for the phytoplankton and the fish schools, resulting in the fishermen's nets often remaining empty. Besides, El Niño is even suspected of having contributed to the downfall of some indigenous cultures. These include, for example, the Moche culture, which resided on the northern coast of Peru from the 1st to the 8th century and likely succumbed to the extreme storms released by El Niño. In this regard, researchers at Ohio State University in Columbus have concluded that the culture's mud brick structures and fragile irrigation systems simply stood no chance against the extreme weather events. However, the conflicting sibling pair has also left its dangerous mark in the recent past. In this respect, it has been determined that the last major global flu outbreaks, as well as the spread of swine flu in 2009, occurred following a pronounced La Niña phase. But what do weather changes have to do with severe disease outbreaks? Well, it's quite simple. Climatic changes also have a direct impact on the behavior of migratory birds, and these, with their long journeys and many stops, are considered important contributors to the formation of new genetic types of flu viruses. In this context, migratory birds, such as wild geese, can transmit bird flu viruses to domestic poultry or even to other animal species. If the infected animals are already carrying a different strain of the virus, the various virus types can exchange genes and alter their genetic material. Ultimately, this recombination can generate a flu virus that can no longer just affect birds but also humans, a colder time of year of ghastliness as of now. It's worth recollecting that the European environment is chiefly affected by the Atlantic, which brings up the issue of what the colder time of year of frightfulness that La Niña is going to bring us. As of now, it ought to perhaps be briefly noted that this term doesn't come from us, but rather defines the titles of certain articles that are currently buzzing through the net. However, be that as it may, according to meteorologists, it's practically as sure as the amen in church that the next La Niña stage is unavoidable. This is because the cool sister generally follows in the footsteps of its warmer sibling, and the past few months have indeed been dominated by El Niño. In Germany, for instance, every month since June 2023 has set a new temperature record, and 2023 can also lay claim to the dubious title of being by far the hottest year since climate records began. Yet now, the weather conditions could tip significantly because La Niña always replaces El Niño. The World Meteorological Association believes that sharply cold temperatures could set in as soon as fall, or by winter at the latest. According to the estimations of the U.S. Climate Forecast Center, there is a 74% likelihood that Jack Frost will make himself comfortable in the Northern Hemisphere until January 2025. Whether the winter will truly be as dreadful as feared in the media is not yet clear. On one hand, there are still significant uncertainties regarding the intensity and duration of the early onset of winter. On the other hand, La Niña doesn't just affect the climate in Europe, but in times when terms like climate change are part of everyday language, an entirely different question arises. How will El Niño and La Niña actually develop in the next few decades or more? Are we facing a super El Niño in the future? Exactly how powerful the effects of El Niño can be is evident from what happened in Australia about a year ago. As early as the first half of September 2023, temperatures in some parts of Down Under were 10 to 16 degrees above the average for that month. While the Australian Meteorological Service had officially declared the El Niño weather phenomenon at that time, the WMO went even further in May 2023, warning of a possible super El Niño. According to this, the development of an El Niño would most likely lead to another increase in global warming and raise the likelihood that further temperature records would be broken. This is far from an optimistic forecast, which was later confirmed by a study published in the journal Nature. Based on a model estimate, it was determined that between July 2023 and June 2024, the average global air temperature could exceed historical maximum values with a 90% likelihood. A look at the statistics shows that El Niño and the global climate are fundamentally closely linked. In recent decades, strong El Niño events have always been accompanied by new heat records in the oceans and atmosphere. However, essentially the developments of the El Niño cycle can not only amplify the effects of climate change, but also moderate them. Studies have shown that we have just emerged from a triple La Niña. This was triggered by the scorching effects of the Australian wildfires of 2019 and 2020, and it caused global mean surface temperatures to remain flat and not rise further despite growing greenhouse gas emissions. However, La Niña didn't really cancel out the effects of greenhouse gas emissions. It merely masked them temporarily. In fact, after La Niña ended, global mean surface temperatures increased abruptly by 0.2 degrees Celsius. While experts fear that El Niño and man-made warming will cause global temperatures to skyrocket in the future, climate change also impacts the overall El Niño phenomena. For instance, this affects the shifting of large-scale air currents, while at the same time, the warming oceans cause the temperature gradient between the equator and the poles to weaken and precipitation patterns to change. Speaking of precipitation, if the subscription button has never been struck by the force of your click, you are welcome to change that now. So feel free to click subscribe so you never miss another video from us again. We'll see you soon.